Hi, I hope you're having a nice day whenever you're watching this. And my name is Francisco Edivaldo de Oliveira Terceiro, and I'm presenting to you today a chapter of my thesis entitled Common Marmosets Reactions Towards Conspecific Arousal. So to look into this type of reactions, we go to consolation behavior, a very well-studied type of behavior, first described in apes back in the 70s. And after that, the scientific community has gathered information and data on canids, corvids, and elephants as species that also display some kind of consolation behavior. Therefore, we started to posit the idea that we need big brains and advanced cognitive capabilities to be able to do such a type of behavior. However, more recently, a study with rodents showed that these species that you see in the below of your screen, in the downside of your screen, that they are a monogamous species that have parental care and that are highly interdependent because they are cooperative breeders. They also are able to show consolation behavior and also coping behavior. And they're closely related species, the one that you see in the upward part of your screen, it's not able to show that, to have this type of behavior. And it's important because these closely related species, it's a promiscuous species with no parental care. So we wonder if this highly interdependent cooperative breeder situation is at play. And of course, that brought our attention to our model species, the marmosets, because they also fit these parameters. Therefore, our goal was to examine empathic-related skills in Callithrix jacchus. To do so, we look into the Yamamoto's model of empathy. It posits that empathy-related skills, require three domains. The domain, as you can see, of prosociality, matching with others, and understanding of others. And importantly, common marmosets have been able to display behaviors in all of these domains. So the next logical step is to ask ourselves if they are really able to show consolation behavior. To try to examine that, we developed this experimental procedure. We have the home cage, and then I added the experimental cage inside the home cage. We allowed 3 of the 4 group members that you can see there to go outside. They would readily do so because they have they like to go outside. It's sunny, it's warm. And then one of the subjects that becomes the focal subject, I would habituate to go into the home cage. Everyone would be habituated in different moments to go into the home cage. And then there, they would receive one of 2 conditions. Either they will get a really desired piece of food, a whole grape actually, or as anyone that has a sibling knows very well, I would tease them by presenting the food, putting the food close in reach of the marmoset, and then when the marmoset tries to grab the fruit, I would remove it, and then I would do this until I would elicit arousal, and I would know that he is aroused because we use the piloerection of the tail as a reliable sign of arousal of the marmosets. All of our groups had 4 individuals, and we had 4 groups. After this, after the condition, the experimental part, the remaining group members would come back to the home cage. Then I would release the focal subject, and after they were back together, I would measure all the affiliative interactions, their frequency, their duration in all of the sessions, and importantly, which subject was starting, what had the initial step towards the interaction. Also, I would record the piloerection of all individuals every 30 seconds during the 10-minute session. As you can see in our first results, our teasing condition elicited more arousal than the feeding condition. However, importantly, you can also see that we have also some arousal in the feeding condition. So to be able to do analysis as sure as we can, what we did is that from now on, we're going to use as independent variable the arousal that the focal displays to the returning group members. So we're going to have focal either aroused or relaxed, because that's what the group members are seeing when they come back. When we do that, we see that the group members themselves, they do get aroused, they have piloerection of the tail, and they do so more often when the focal subjects are aroused. And we see that this result is true for all sex status and common marmosets. With this, we understand this as an evidence of emotional contagion. Furthermore, we also see that the probability that the approach of the affiliative interaction is made by one of the returning group members is higher when the focal is aroused, and this is more true when the focal is a male. And finally, the probability that the first affiliative interaction is made by the group members, it's also true for both sexes, for both focal sexes, but it also happens more when the focal itself is aroused. All of this together, we understand that this indicates that Callithrix jacchus have a broader repertoire of empathic-related skills. And then rather the big brains, the puzzle that starts to form is that all these subjects, what they have in common, instead of big brains, are high levels of either ecological or of interdependence in their reproduction, which shows to us the importance of the biological consequences of social environments. Thanks for your patience, and I will be here to answer your questions. Thank you.